No,
I feel you.
no.
So quiet. Yeah, so there's only 6 students registered for this class. I kept thinking they were going to cancel it because they said they had to have at least 9, but then they never canceled it, so here we are. And only 3 are here. So, And I don't know, I sent out an email or an announcement or something saying like, hey, you know, if you can't come to class or whatever, I'm going to put this on Zoom, you know, but no one's gone on Zoom either. So, so I don't know what's up with that. Anyway, I am Charity Bankhead. I'm your instructor for the semester. Let's see. All right. Let's see. Jesus, Dax, Haley, no. Alyssa, no. Sierra, yes. Okay. There you are. Okay. So, all right. All right. So we'll talk about the course outline. So y'all know how to go on Canvas? So, okay, so Canvas is when you go to the home page of wc.edu, and then if you click on online courses, then that's what we call Canvas. Okay, so I know they were having some issues with getting the students onto Canvas, but it looks like you guys are there, I think, because I was able to see y'all on my attendance. So that means I think you should be able to see this too. So right up here, if you click on My WC, oh, not My WC, sorry. Online classes is what I meant. Click on all classes. And that's what we call Canvas. And then you should see all of your classes on here, hopefully, if your instructors have published them. And then you can just click on our class. And then from there, see, I put a link to right here where you can join Zoom. So if anytime you're not here, if, you know, whatever, if you want to, you know, watch on Zoom, you can do that. I'll try to have, you know, use the Zoom. Especially, I don't know, I might give it up if no one ever goes on, but we'll see. But I also like doing it just because it records. So, all right, so then you can click on modules. And then there's the course outline right there. All right, so that's what this is. All right, so this is co-rec. So we're doing 0332 developmental math for the first 8 weeks. And then for the second 8 weeks, we'll have 1332 contemporary math, which is your credit math class. So hopefully you guys are non-STEM majors. That's kind of the idea. You don't need to take college algebra. So this course won't get you to college algebra. It'll just get you to contemporary, which is a credit, but it's not college algebra. Here's my office phone number and my office location. And I have office hours in the afternoon. So they want you to make an appointment for office hours. And they kind of like don't really want you going in our office either. So I'm not even sure why we have office hours, but so I went ahead and just put my cell number on here. I'm assuming y'all are adults and aren't gonna like call me 1,000 times at like 3 in the morning. You know, but if you need something, you can text me, you know, if you have a question. But let me say, like, if you are gonna like either text me or email me, either way, like if you say something like, when is our test? then it would be helpful if you tell me which class you're in. Because people email me like, when's our test and stuff, and I'm like, well, what class are you in? So that would be helpful. You know, and if you're going to text me, also let me know like who you are and what class you're in. So, so you can, like, so you can make an appointment, like we can meet in person, but we'll have to do it like outside of my office, because I guess because our offices are too small, so they don't want like people coming in there. So like if you want, we can meet and we can sit, like there's a bunch, like y'all know where the Academic Support Center is? So like we can meet in there if there's room in there, or we can, you know, if the weather's okay, we can even sit at the picnic tables over there, because my office is just right on the other side of the picnic tables from the Academic Support Center. So. Okay, so y'all do need to have MyLabs Plus. The actual physical textbook is not really necessary unless you just want to have it. But you do need to have MyLabs Plus. And so, so normally you would click through on Canvas to do that, but it's actually not working right now. So you're just going to go to this link right here, which is wc.mylabsplus.com to register for it. We're not using any calculators, but you know, you would probably want to bring like paper, pencil, etc. to class for notes. And I provided the notes for today for y'all, and I might just go ahead and keep on doing that because there's only 6 of y'all, so it's not that big of a deal for me to print the notes for you, I guess. Normally if it was like a full class, I wouldn't, but. Okay, so yeah, so no calculators basically in this class. Once we get to 1332, you will be using a calculator. All right, Academic Support Center for tutoring. So as far as attendance, I mean, I think you should come to class. It's important. Obviously, if you're sick, don't. But just like send me an email to let me know like why you're not coming to class. And then if you can, like I said, I'm going to try to, you know, keep using Zoom so that you can still like watch class from home. All right, so the homework is on MyLabs Plus. Have you guys used MyLabs Plus before? No? Okay, so like I said, we're going to go to wc.mylabsplus.com. Okay, so when you log in, so the username is going to be the same as like your email and stuff. And then your password is going to be your 8-digit date of birth. That's what I've been told. All right. So we do have a link to MyLabs Plus in Canvas, but I'm told it's not working. So just go ahead and go to wc.mylabsplus.com, and it's your password is your 8-digit birth date. All right, so so once we sign in there, you'll probably only have one class in here to click on. Let me click on that. Okay. All right, and then you can basically just go over to click on assignments on the side. And I didn't put any due dates on yet, but typically what I will do is it'll be due like a week from whenever I teach the lesson. So like your first like homework assignments should be due Monday before class on Monday. That's the idea. I'll get in there and set up those due dates soon, but now you know. Okay. And so since y'all haven't used My Labs Plus before, this orientation assignment should be helpful to like help you get used to how to use it. But I'll go ahead and open up one of the actual homeworks. All right. So we can just click on question number 1. Let's see, this assignment's kind of, okay. All right, so let's just say that, okay, so if you don't know how to do the problem or you need help, you can click on question help right here. And the most popular option to click on here is view an example. And so that will give you an example that's really similar to that problem, and it'll show you step by step how to do it. Just keep clicking continue, and it'll show you step by step how to do it. And then you can try it, you know, and you can type in an answer, and you can just hit enter to check the answer. And then if it's wrong, it'll tell you that's wrong, and it'll tell you blah, 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 this is what you need to do. You can hit enter again. And then you have like 2 more chances to enter an answer. And so then if you get it wrong 3 times, it'll eventually tell you what the right answer is. And then what you could do is you can click on similar question, and then you basically just have a similar question. You can try it again, and you can do that as many times as you need to in order, you know, before you get it right. And, you know, if you're having a lot of trouble with it, you know, there's other options on here. You can do like, help me solve this. And if you're really struggling or whatever, that the view an example doesn't work, you can also click on Ask My Instructor. And what that will do is that will send me an email with a link to that question. And then you can type something in, because, you know, a lot of times I can't like explain the whole problem on an email, because I mean, you might as well just look at a view example or help me solve this for that. But if there's like a specific maybe part of the example that you didn't understand, like say, oh, I looked at the example, but I didn't understand, you know, the 3rd step or the last step, or I didn't understand where they got the 3 from or something like that, you know. And then also, you know, even if I can't help you on email, I might be able to help you, you know, like if you come to my office or the next time I see you in class, or, you know, if you make an appointment with me on Zoom or something, and then I can like explain it to you, something like that. So that's good. Okay. And so, yeah, I mean, every time you check the answer, it automatically saves your progress. So all right, so there will be a 10% late penalty per day if it's late, which I think isn't too bad, because you have a week to do it, and then it's only 10% off per day that it's late. So hopefully you'll do them on time, but if not, there's that. You can still do it. And then, so the homework, that's 15% of your grade. And then tutorial hours is 5% of your grade. So that means that that's 12 hours in the academic support center getting help, or even just doing your homework in there. You can also get help from doing, so in Canvas, there's a link that says tutor.com. Yeah, tutor.com. You can click on that also. So you can get help from that at any time, 24/7. And then if you're, so during the business hours when the support center is open, and I think even sometimes like later at night, they have tutors available from the actual college here on tutor.com. And so if you are working with one of those tutors, that also counts for your tutorial hours. All right. And then we will have paper tests in the classroom, and that's 60% of your grade, and we will have a final exam. And I believe the final exam is on MyLabs Plus. So what we'll do is we'll go to like a computer lab for you to take your final exam. So it'll still be, you know, like an in-class setting, not like taking it at home. All right, and if you have any disabilities, you need to contact Dawn at the disability office. There's the information for that. And if you need, you know, if you have needs of things like food, housing, basic needs like that, we also have help for that on campus as well. And there's the phone number to contact for that also. Okay. Does anybody have any questions? All right. I will go ahead and hand you the notes for today. So like these copies of the notes like this are available on Canvas under modules. But like I said, since there's so few of you, I'll probably just print them out for you. And I also have, there's videos on Canvas that go along with these notes. I actually got those from another instructor, Mrs. Burt, who did all this over the summer. So since she already had those videos, I went ahead and put those up. But like I said, I am trying to, I'm recording this on Zoom so that I'll have my own videos. So, okay, let's see. Hopefully it'll work out. Seems to be working. Okay, let me try that. Okay. All right, so let's see. Okay. Yeah. Trying to work for this. I'm trying to get it where I can record it, but okay, I'm sharing the screen. Close this. And then okay. Okay, I think it's working now. Cool. All right. All right. So 5.1 is about primes and composites. So first of all, we need to know what are the natural numbers. So those are basically just the counting numbers starting at 1, 2, 3, 4, 5, goes on up forever from there. Those are the natural numbers. All right, so we want to define the term divisible. One number is divisible by another if the quotient of the numbers is a natural number and the remainder is 0. So for example, 12 is divisible by 4. So the quotient, meaning 12 divided by 4 is 3. So 3 is the quotient, and that's a natural number. All right, with no remainder. So 12, therefore we can say that 12 is divisible by 4. All right, so if A and B are natural numbers and A is divisible by B is the same as saying that B is a divisor of A. And so there's the notation for that. So B is a divisor of A, or B divides A is another way to do that. So this would say 4 divides 12, which means 12 is divisible by 4, or 4 is a factor of 12. All right, so a divisor is also the same thing as a factor. We can say that 4 is a factor of 12. All right. And then that also, so another thing we can say then is that 12 is a multiple of 4. So a multiple of a number is the product of that number and some natural number. So 12 is a multiple of 4. And so if we wanted to figure out what are the factors of 12, so that would be 1, 2, 3, 4, 6, and 12. Those are all the factors of 12. Okay, so most of the factors are going to be something that's smaller. Okay, so there's a finite number of factors, whereas multiples of 12 would be, for example, 12, 24, 36, 48, 60. So anything multiplied by 12 gives you a multiple of 12. So there's an infinite amount of multiples because you can just keep going up and up. All right, and then the greatest common factor, also known as the GCF for short. So that's the largest number that is a factor of 2 or more natural numbers, also known as the greatest common divisor. So again, that's a factor. So the GCF is going to be something that's smaller. And then least common multiple is the smallest number that is divisible by 2 or more natural numbers. So LCM for short. So that's a multiple. That would be something that's bigger than all the numbers. And a prime number is a number that has exactly 2 factors, which is 1 and itself. So for example, prime numbers would be 2, 3, 5, 7, 9. Not 9. I got carried away. 2, 3, 5, 7, 11, 13, 17, etc. So those are some examples of prime numbers. And then a composite number is basically all of the other numbers that are not prime. So it has more than 2 factors. All right, and the number 1 is considered to be neither prime nor composite. So it's like a special case. And the prime factorization is when you factor a composite number into the product of all of its primes. All right. So this section happens to have just a lot of terms and definitions to go over before we do some actual examples. All right. Okay, so then we'll talk about the tests for divisibility. So these are rules or tests for divisibility that often provide a shortcut to determining if one number is divisible by another. If no test exists, long division may be used. All right, so tests for divisibility are also tests for factors. For example, if we find that 12 is divisible by 4, we also know that 4 is a factor of 12. All right, so first of all, how can we figure out if a number is divisible by 2? Okay, basically all the even numbers are divisible by 2. So that would be starting with 0, and then 2, 4, 6, 8, 10, 12, 14, etc., so on. Okay, so those are the even numbers, and those are divisible by 2. Right, so basically saying that it's divisible by 2 is the same thing as saying it's an even number. Okay, and then to see if something is divisible by 5, basically you'll know if the number ends in either a 5 or a 0 as the final digit. So any number that ends in a 5 or a 0 is divisible by 5, otherwise it won't be divisible by 5. Any number to be divisible by 10, it has to end in a 0. So any number that ends in 0 is divisible by 10, otherwise it's not. And then, let's see. So maybe I'll go along with this. I can do some, yeah, let me go ahead and do a couple examples. On the next page. So let's see, number 1, determine whether the statement is true or false. If the statement is false, make the necessary changes to produce a true statement. So the notation means that B is divisible by A. Do you think that's true or false? So if we look, okay, so it means that, yeah, yeah, so B divides A. In other words, A is divisible by B. All right, so that's false. So we could say it means that A is divisible by B. So if we switch A and B, that would make that become a true statement. Or we could say it means that B divides A. That's how we usually read that notation, is to say that B divides A. All right. Use rules of divisibility to determine whether 6,248 is divisible by the following numbers and justify each answer. So is that number divisible by 2? Yes. We know that because it's an even number, because that last is an even number, it's an 8. So, yes. Okay, so basically, we could say we know that 8 is divisible by 2. Or in other words, it's an even number. Okay. All right. Let's see, now I didn't talk about the divisibility rule for 3 yet, so I'll go ahead and talk about that real quick. So divisibility by 3. A number is divisible by 3 if the sum of the digits is divisible by 3. Okay, so let's try that out on this example right here. All right, so that means, so 6,248. So 6 plus 2 plus 4 plus 8. All right, so that's 8 and 12. That equals 20, right? Okay, so is 20 divisible by 3? No, it's not. So therefore, no, this number is not divisible by 3. All right. So part C says, is it divisible by 4? Okay, and we do have a rule for that over here. Let's see. All right, so a number is divisible by 4 if the number named by its last 2 digits are divisible by 4. Okay, so let's apply that here. All right, so look at the last 2 digits. So that would be 48. Okay, so we want to figure out, is 48 divisible by 4? So if you know your multiplication tables, you know that 12 times 4 is 48. So yes. And by the way, if you don't know your multiplication tables, you really need to, because as I said, we won't be using a calculator for our tests and such. So. All right, and then is the number divisible by 5? No, because it does not end in a 5 or a 0. It ends in an 8, not a 5 or a 0. All right, divisible by 6, so let's look at our rules. A number is divisible by 6 if it is divisible by both 2 and 3. All right, so is this number divisible by 6? No, because it's not divisible by 3. All right, let's see. Is it divisible by 8? All right, so the rule for that, a number is divisible by 8 if the number named by its last 3 digits are divisible by 8. Okay, so 248. Okay, well, I don't know off the top of my head necessarily if that's divisible by 8. So what I would do is do long division. But I mean, at least I don't have to do a long division on the whole number. I just have to do it on 248. So let's see if 8 goes into 248. So 8 goes into 24 3 times. 3 times 8 is 24. 24 minus 24 is 0. Bring down the 8, and then 8 goes into 8 one time with nothing left over. So yes, that'll be a yes. Any questions so far? All right, is it divisible by 9? Okay, a number is divisible by 9 if the sum of its digits is divisible by 9. All right, well, we already did the sum of the digits when we were doing the checking for 3 up here. So the sum of the digits is 20. And then is 20 divisible by 9? No. There you go. Okay, is the number divisible by 10? No, because it does not end in 0. All right, let's see, is it divisible by 12? Let's see, we don't have a specific rule for that, so just divide it out. 12 into 62, 48. So 12 would go into 62 5 times. 5 times 12 is 60. 62 minus 60 is 2. Bring down the 4. And then 12 goes into 24 2 times. 2 times 12 is 24. 24 minus 24 is 0. Bring down the 8. And 12 doesn't go into 8. So that's going to be a no. Because you would have to put, yeah, you would have to either, if you're going to do a fraction, I mean, it goes in 0 times, and then you would have like 8 over 12, or you could do a decimal. But either way, it's not going to go in evenly, since 12 doesn't go into 8. Yeah, no. And even though it doesn't say this on our list of rules, I think that we could say, to me, a clue would be the fact that it's not divisible by 3. So I know 3 is one of the factors of 12, right? And so if the number isn't divisible by 3, then it can't be divisible by like any multiple of 3. Basically, it can't be divisible by 12 either. So, all right. So I think we went over all of those then. Okay. Is it like super choppy when I'm like on the screen and stuff? It's not, I mean, it's not horrible. Okay. All right. Can I turn up the brightness maybe? Okay. I don't know. I'm not sure how to turn up the brightness on that screen. Oh, let me, maybe right around there, let's see. Okay, let's see. Okay, so number 3, basically same thing. All right, so is this number divisible by 2? Yes, because it ends in a 6, which we know 6 is divisible by 2. In other words, it's an even number. All right, divisible by 3. So to determine that, I need to add up all the digits. All right. So 2 plus 4 plus 3 plus 1 plus 6. Okay. That's 8, that's 11, 12, 18. 18. All right, and then is 18 divisible by 3? Oh, wait a second. Yeah, you know, you're right. That's right. That's wrong. Yeah. Yeah, I was, what I did was I was like 2 plus 4 is 8. Yeah, that's what I did. Okay, so that'd be 16. Okay. 16 divisible by 3? No, so that's a no for that one. All right, let's see. Okay, so to figure out if it's divisible by 4, we just look at the 16 and we just ask, is 16 divisible by 4? Yes, so therefore, yes, it is. Okay, is it divisible by 5? No, because it ends in a 6, not a 5 or a 0. So that's no. Is it divisible by 6? No, because it's not divisible by 3. Let's see, is it divisible by 8? So we would have to figure out if 316 is divisible by 8. So let's see. I was going to say, like, let me check. Is it divisible by 4? Yes. If it wasn't divisible by 4, then I would automatically know it's not divisible by 8. But it is divisible by 4. So let me go ahead and check this. So 8 goes into 31 3 times 8 is 24. 31 minus 24 is 7. Bring down the 6. I don't think that goes in evenly. Because, yeah, it would go in 9 times, which would be 72. So basically, like, has a remainder of 4. So, nope. All right, let's see. Is it divisible by 9? Well, since it's not divisible by 3, I already know that's a no. Because it's not divisible by 3. Okay. Is it divisible by 10? That's a no because it ends in a 6. It has to end in a 0 in order to be divisible by 10. So that's also a no. Divisible by 12. Well, we could divide it out, but like I said, you can already know that if it's not divisible by 3, it can't be divisible by 12 either. All right. Any questions? Okay. All right. Determine whether the given statement is true or false and indicate why this is so. All right, so first of all, we got to make sure we can read what it's saying. So what it's saying is 3 divides 8,154. Okay, so then we would just check it. So 8 plus 1 plus 5 plus 4 equals 18. Right, and then is 18 divisible by 3? Yes. So therefore, it is true. Okay, so that number is divisible by 3 because the sum of the digits is also divisible by 3. Okay. All right, find the prime factorization of 24. Use exponents to show any repeated factors. Okay, so I would do this by making a factor tree. Factor trees are really useful. I still, you still need to use factor trees, I think, even if you were to go to college algebra and trigonometry and calculus, I would still be using factor trees. It's useful. Okay, so 24. So I'm going to start with the smallest possible prime factor, which would be 2. So 2 goes into 24 12 times. All right, and then we can break down the 12. 2 also goes into 12 6 times. And then 2 also goes into 6 3 times. So then 3 is a prime number. So now I'm done with my factor tree. Okay, so what this tells me is that 24 is equal to 2 times 2 times 2 times 3. All right, and I'm using the dot to indicate multiplication. All right, but it does say use exponents to show any repeated factors. So that means for my final answer, since there's 3 2's, I'm going to write that as 2 to the 3rd power times 3. Okay. Any questions about that? Okay. All right, and then number 6 says find the prime factorization of the composite number 285. Use exponents to show repeated factors. Okay. There's not enough space in there. All right. Or I could do it on the side. Maybe that's better. All right. 285. Okay, y'all can see. Okay. That color's kind of hard to see. All right, 285. Okay, so let's see. So does 2 go into that? No, it's not even. Let's see, does 3 go into it? Well, 2 plus 8 is 10, plus 5 is 15, which is divisible by 3. So yes, 3 does go into it. Now, I guess we could have said 5. That would have been maybe easier. Like it obviously is divisible by 5, but I like to try to do the smallest one. Just seems to work better to me. All right, so now we have to divide 3 into that. So we know it's going to go in evenly. Let's see. So 3 would go into 28 9 times, which is 27. Maybe, let's see, I'll go over here and just divide it. 3 into 285, so that goes at 9 times, 27. 28 minus 27 is 1, bring down to 5. 3 goes into 15, 5 times. Okay, so 95. So 3 goes into 285 95 times. And now let's work on breaking down the 95. So we can just ask ourselves, we already know 2 is out. Does 3 go into that? Well, 9 plus 5 is 14. 14 is not divisible by 3, so 3 is done. But we do know it's divisible by 5 because it ends in a 5. Okay, so 5 goes into 95. So 5 goes into 9 one time. 1 times 5 is 5. 9 minus 5 is 4. Bring down the 5. So 5 goes into 45 9 times, right? Okay. Is that right? Yes, that's right. Yeah, there you go. So 19. Okay, now 19, 5 doesn't go in, and neither does 7 or 11. So 19 is prime, so that's done. So our prime factorization for 285 is equal to 3 times 5 times 19. And that's our prime factorization for that number. So no repeated factors in that one. All right. I'm guessing we pull out. Oh, okay, yeah, we still have this page. All right, number 7. All right, find the greatest common divisor of 66 and 42. And I normally refer to that as the greatest common factor. In other words, the GCF. Okay. Okay. So a great way of doing this is using factor trees. All right. So I'm going to start by doing a factor tree for each number. So for 66, 2 goes into 66 33 times. 2 doesn't go, but 3 goes into that 11 times. All right, 11's prime, so there's my factor tree for that one. Now I'll do a factor tree for 42. So 2 and 21, and then 3 and 7. Okay, so greatest common factor. So what do these factor trees have in common? They each have a 2, they each have a 3. So multiply those together, that's 6, that's your GCF. All right. Let's see. All right, let's just go ahead and try that same method for number 8. Find the greatest common divisor, or in other words, the GCF, of 132 and 36. All right, so that's going to be 2. Okay, 2 is going to go into that 66 times, I believe. Then we've got 2 and 33, and then we got 3 and 11. Okay, there's that. For 36, that's 2 and 18, that's 2 and 9, that's 3 and 3. All right, and then just figure out what do they have in common. So they each have 2 2s, and they each have at least 1 3. So we got 2 2s and a 3. Does that make sense how I'm doing that? So it's just what they have in common. And then multiply all those together. 2 times 2 times 3, that's 12. 12 is your GCF. Okay. find the least common multiple. Okay, so you're going to use least common multiple. The main time that you're going to use that is in a little while later when we do like adding fractions and you have to find the least common denominator or LCD. So if you've done, if you've done any fractions anytime recently, that might sound more familiar to you, right? I mean, you got to find the LCD for your fractions. That's basically what we're doing here. Okay, and we can also do this using factor trees. All right, now there's other ways of doing this, but I'm just going to stick with the factor trees for right now. Okay, 198, so that's divisible by 2, and then that's going to be like 99. All right, and then that's going to be 3 and 33, and that's going to be 3 and 11. Okay, and then for 44, that's going to be 2 and 22, 2 and 11. Okay, so the least common multiple, so you have to include, so this is a little bit different now. So before we were doing the greatest common factor, now we're doing the least common multiple. So every factor from each one of those denominators has to get included into your least common multiple. So let's see. And you basically like look at it and see like which one has the most 2's. Okay, well this one has 2 2's. So that means my LCM has to have 2 2's. Which one has the most 3's? This one has 2 3's. So my LCM has to have 2 3's. Okay, so when I have these 2 2's, that takes care of this 1 2 in the other number. Okay. Okay, so besides 2 and 3, we also, each of them also has one factor of 11. So that also has to get included. So we multiply all those together, and that's going to give us our least common multiple. All right, so that's 4 times 9 times 11. So 4 times 9 is 36. 36 times 11. That's 396. Right? Any questions about that? All right. Number 10, find the least common multiple of those. All right. I might run out of room on that. I don't know. Probably gonna run out of room. Let's see. I know I can do a 2 in there. And then that's going to be 168, I think. Yeah, 168. And that's 2. And then that'll be 84. 2, 42, 2, 21, 3, and 7. Oh, I managed to squeeze it in. Okay. And then 266. That's 2. And then that's 133. And that is, let's see, so 2 is a no, 3 is a no. Is anything going with that? Let me look at my divisible. Let's see if there's anything. I remember when I was a kid, I learned one about 7, but yeah, that's all on here. So, yeah, because 2, y'all got anything on that? No? Because I can't think of anything. Let's see. 2's no, 3's no. So yeah, maybe that's that. Okay. So well, actually, wait. I think actually 7 might go into that. Let me just see. 7 into 133. That would be 7 goes into 13 once. 1 times 7 is 7. 13 minus 7 is 6. 3 times 3. And then that would be 9, right? 9 times 7 is 63. So there you go. Okay. All right. And yeah, there we go. 7 and 19. And 19 is definitely prime. All right. Oh, now for finding least common multiple. Okay. All right, so how many 2's? 1, 2, 3, 4. So that's 2 to the 4th power. And then we have a 3 right there. 3 right there. And next we have a 7. They each have 1 7, so we just need 1 7. And we also need 19. Oh, well, that's fun. Fun. All right. So 2 to the 4th, that's 16. 16 times 3. That's 48. Multiply that by 7. And that's 336. Probably could have figured that out without actually multiplying it. We're not moving enough, but that's okay. I guess, yeah, just as well. All right, and okay. So it's 27 plus 5 will be 32. 27 plus 3 will be 30. And then okay, I got 6,384. Did y'all do it? Or y'all think I did that right? Okay. All right. I would not put something like that on your test. That is too much. But I can't make any promises on your homework because I don't make that up. Computer generates it. So. All right. Okay. Okay, application problems. Let's see how we're going to do on time. Okay, about a few minutes. Try to finish this up. A relief worker needs to divide 600 bottles of water and 216 cans of food into groups that each contain the same number of items. Also, each group must contain the same type of item, bottled water or canned food. What is the largest number of relief supplies that can be put into each group? So in other words, they're asking us to find the greatest common factor because they want to divide each one of those things up into the same, like groups of the same number. So we need to find the greatest common factor. Okay, so for 600, that'd be 2 and 300, 2 and 150, 2 and 75, and then 3 and 25, which is 5 and 5. And then 216, that's going to be 2, 108, 2, 54, 2 and 27, and then 3 and 9, 3 and 3. Okay, and we're looking for greatest common factor. So how many 2's? There's 2's right here, and there's 3 2's right there. So that's 2 to the third power. And then this one has 3 3's, so we have to have 3 to the third power. And then this one has 2 5. Oh, wait. I did that wrong. I'm doing greatest common factor, so I have to go with which one has a smaller number of 3's. So that's only 1 3 right there. So only 1 3. And then this, yeah, and then this one has 5's, but that one doesn't. So no 5's in the GCF. All right, so that's it right there. So 2 to the third power is 8, and then 8 times 3 is 24. Okay, so 24. So you're able to take, so that's your greatest common divisor of those two numbers. So like you're able to take 600 and you can divide that into groups of 24, and you can take 216, you can divide that into groups of 24 as well. Because they wanted the groups to have the same number of items in them. All right. All right, number 12, 2 people are jogging around a circular track in the same direction. One person can go completely around the track in 10 minutes. The second person takes 12 minutes. If they both start running in the same place at the same time, how long will it take them to be together again at the same place if they continue to run? So that's talking about least common multiple of 10 and 12. Okay, so luckily those are small numbers. So for 10, that's just 2 and 5. And for 12, that's 2 and 6, and then 2 and 3. So least common multiple is a bigger number. Greatest common factor is a smaller number. Least common multiple is a bigger number. So we're including more stuff in our least common multiple. All right, so we have to have 2 2's, and we have to have a 3, and we have to have a 5. So 2 times 2 times 3 times 5. All right, so that would be 4 times 3 is 12. 12 times 5 is 60. So 60 minutes, or in other words, an hour. I wouldn't be running that. If that was me, I'd just be like, I wouldn't. All right. So that is all. You need to go ahead and go to My Labs Plus. And if you haven't, you can pay for it with your, like a credit or debit card, or if you're on financial aid or you don't have the money or whatever, just click on like pay later, and then you can go ahead and get right in and you can pay later. It gives you like 2 weeks. So go ahead and do that so that you can start getting your homework done. All right. Any questions about anything? All right. I'll see y'all Wednesday.